So I went ahead and took the liberty of writing out a little bit to get us started on these checkpoint exercises, so the video isn't quite as long, but I will explain the first parts that I did. We're asked to estimate, again, square roots and cube roots, and we start off with estimating the square root of 29. So we look for the two closest perfect squares to 29, and that gives us 25 and 36. 29 is only 4 away from 25, but it's 7 away from 36. So we know to the nearest integer, the square root of 29 is going to be approximately the square root of 25, and that's 5. Now with the cube root of 52, we're looking for perfect cubes. So if we look at 4 cubed, that's 64, which is greater than 52. And 3 cubed is 27, which is less than 52. And we know that 52 is going to be a lot closer to 64 than it is to 27. So we know that this is approximately the cube root of 64, which equals 4. So t equals the square root of 216 over 4. We're given that the time it takes for an object to fall from a specific height is the square root of h over 4. So I went ahead and substituted our h of 216 into that equation. And we want it to the nearest quarter of a second as far as our estimate is concerned. So we need to estimate the square root of 216 first. So let's look at what are the two closest perfect squares to 216. Well, we know what 15 squared is 225. And that's bigger than 216. And we know that 14 squared is 196. So somewhere between here is 216, but here's only a difference of 9, whereas here's a difference of 20. So we know it's closer to 225 than it is to 196. So we know it's closer to 15 than it is to 14. So now let's take our two values to look at exactly what this means. 14 divided by 4 is 3.5. So we know t is somewhere between 3.5 is less than t, and then 15 divided by 4 is 3.75. So we know t is somewhere in between here, and it's closer to 3.75 than it is to 3.5. And the reason we know that is because, well, the actual square root of 216 is closer to 15 than it is to 14. So the square root of 216 divided by 4 is going to be closer to the square root of 225 divided by 4, or 15 divided by 4. So we know it's closer to this value here than it is to this value here. So that gives us all we need. To the nearest 0.25 seconds, t is 3.75 seconds. So it's going to take approximately 3.75 seconds using this formula for the object to hit the ground from a height of 216 feet. All right, on number 4, we're asked to order the numbers. So we're going to have to use some approximations. Let's approximate the square root of 5. What are the two closest perfect squares to the square root of 5? Well, one that's pretty close is going to be 4. And then what's the next perfect square above that? It's going to be 9. Now we know it's a lot closer to 4 than it is to 9, because here's a difference of 1, here's a difference of 4. So this, to the nearest integer at least, is going to be approximately the square root of 4. So this is going to be approximately 2. So now let's look at the square root of 10. What are the two closest perfect squares to 10? We have 9, so that's 3 squared. And then 4 squared is 16. And again, this is a lot closer to 9 than it is to 16. So we know to the nearest integer at least, this is going to be approximately 3, because the square root of 9 is 3. So now we also know that it's going to be bigger than 3, because the square root of 9 is 3 and 10 is bigger than 9. So let's put these in order. We're going to have 2 as our smallest value, so as our approximation. So we know we're going to have the square root of 5 at the bottom. Then we have 3, because we know that 3 is less than the square root of 10, because 3 is the square root of 9. Then the square root of 10. and then 6. All right, last but not least, we're given a cube with a volume of 530 cubic inches. And we're asked to estimate the side length of the cube to the nearest integer. Thankfully, this is a shorter problem because we're only looking at the side length to the nearest integer. So what we want to look at is what are the two closest perfect cubes to 530? Well, let's look at what is 8 cubed. That's 8 times 8 is 64, times 8 is 512. So we know that, let's go ahead and solve first so we can see what we're doing. We know s cubed equals 530. Let's take the cube root of both sides so we know that s equals the cube root of 530. And then if we look at our number line, we know that 8 cubed is 512, so that's one of the perfect cubes. And then 9 cubed is going to be 729. So we know that somewhere between here is 530, and it is going to be a lot closer to 512 than it is to 729. So to the nearest integer, we know that the side length is approximately 8 inches because this is 8 cubed and this is 9 cubed. So we know it's closer to 8 than it is to 9. So the approximate side length to the nearest integer is 8 inches.